Welcome to series of database management system lectures. Today we'll be discussing about Unit 3, Topic 1, Indexing in Database. What is indexing? Indexing is a special technique used in database management system to reduce search and then access time. To improve the performance of your database, we use indexing as a technique. Now let us get deep dive into this indexing with an example. Let us say that this is an employee table which contains 100 records, right? So we have various attributes, that is employee ID, employee name, job name, manager ID, hire date, salary, commission, and then department ID. So these are the various attributes that are there for the employee entity, and we have stored this information. Now, how this table of contents are being stored in the memory? Let us see that. Now, this is our secondary storage memory. So here, the complete memory is being subdivided into various blocks. This is block 1, this is block 2, and this is block 3. Okay? Block 1 will be started at memory location 1000. Block 2 will be started from the memory location 1020. And here is block 3, which will be started from 1030. So this is how we have the memory storage area. Now, let us, the first 5 records will be taken and pushed into and placed into this. These 5 records will be placed in this first block. Okay. So this is how in the secondary storage area, the data is going to be stored. Till 99 or till 89, the first 5 records are saved here. And the next continuation of the records will be stored in the second block. Okay. So here is the second set of records. Now the second set of records will be placed in the second block. Okay. Now the next set of records will be stored in the third block. Right. So assume that we are dealing with thousands of records, and then we are moving all that data here. So this is how the whole table of contents will be stored in the secondary storage area in various blocks. Right. Now, when we made a query to retrieve the content of an employee whose employee ID is 68, I need to retrieve the information about the employee whose record can be identified uniquely with the help of this ID number. Now, when this query has been written like this, select, I wanted to retrieve all the content from the table. So that's the reason we are mentioning asterisk here. Start from table name called as employee. Now we are using where clause because we wanted to retrieve only that particular record number EMP ID, where EMP ID equals 68484. Okay. Now, if this query is being written, then every time the query processor should start from here. It should access each and every record and compare whether the employee ID is matching to this or not. And then it will search for the next record and it compares. So it needs to access each and every record and compare the ID number, which will be a tedious job and the time consumption one. In order to overcome with that sort of thing, indexing technique is being implemented to reduce the search time, access time, and the retrieval time, right? So now we do not know that in which particular block this employee ID information is stored, right? So when we have splitted the data in various blocks, we need to maintain another data structure called as index. We need to maintain an index table. Okay. This index table will have the structure called as, it contains only two pieces of information. One is, it contains two pieces of information. One is search key and the next one is data reference key. Okay. What do we mean by a search key? Now, from the given table, identify the attribute which is key attribute. So employee ID is the key attribute. So we mention here as EMP ID will be taken as a search key and the data reference one will maintain a group of references or the pointers which will give the address for the data which has been stored. So this is how an index structure, index table will be created. So let us look at the structure of it. Yeah, here is the structure, how an index table can be created. Okay. Let us look at the example. Now here we will maintain all the information. Now what is employee ID here? 68319 is the first employee ID number. And where from I will retrieve that information. I can get that information. Now search where it is in block B1. So B1 has started from the address point called as 1000. Okay. Similarly, the next is 66. Now here we will have the other set of values. 1002, 6, 8, 10, right? So we'll have the addresses for each and every record. And the next record can be fetched from here. 66928 is the ID, employee ID, which can be found from the memory location 1002. Okay. So this is how we maintain all the information about the records which are available. The next one will be 67832, which can be found from 1006, right? So we will maintain the same thing for all the existing records. Okay. So this is how an index table can be prepared, and whenever there is a match. Now, when a query is being made, then it will first access the index table. Index data structure is accessed. From here, it conducts the search and it finds the record. It finds the record and then it is paired up with the address. Then we will be able to access to the record. Okay, this record can be fetched here, right? So this is how you will be able to retrieve the information. Now at this point of time, I need not access the disk storage till now I get the address of that particular one. So we are going to reduce number of disk accesses. Now, every time when a query is made, it searches here and it retrieves the data from the secondary storage area. That operation is called as swapping in. So we are bringing the data from secondary storage onto the RAM memory. Once the operation is being done, then again we will push the data from RAM memory onto the secondary storage area, that is called as swap out. So we are going to reduce the swap in and swap out times for reducing the disk access. So this is being done by indexing concept. Now, with respect to types of various file organization mechanisms, we use this indexing technique on these two. The first one is sequential file organization, which can also be referred to as ordered index file. Let us see how it will be. In the sequential file organization technique, we store all the information about the employees using a search key. All the records will be stored into this index table and the associated addresses here, right? So as the name itself gives the information that everything will be ordered. Before we store any data, all these key attributes are going to be sorted accordingly, and that can be stored here. And the associated addresses are also going to be stored. So this is how the sequential indexed file organization technique works. Now, what can be the speciality of it? Now, the search key will be unique as it is a key attribute. Second is search key will always be ordered, right? And the third point is the associated addresses for the search key may not be ordered or unordered. Ordered or unordered. So these are the specialities for the sequential index file organization technique upon which the indexing mechanism is implemented in this manner. Now, what can be the advantages of it? What can be the advantages of it? Now, as it is in sequence order, searching for it will be very easy, right? So searching time obviously decreases. And the second one is access time will also be reduced to a great extent. Now, third point is that if the data is maintained in a random manner, then you will not be able to design the index table which can be suitable to that requirement. Every time we may not expect that the data will be in ordered manner, right? And the fourth one is you are going to take a certain amount of memory space for maintaining another data structure called as index table, right? So these are the, till here, these are the advantages and this can be taken as the drawbacks, right? So the next advantage here is a lot of disk access will also be reduced. Disk access is also reduced to a greater extent, and then more number of I/O cycles are also reduced with the help of this, right? Now, now we can relate the same thing with the help of our routine example. Let us take our real world example, that is usage of books. How do we use the books? Now, books generally contains a minimum of 100 pages, right? Now, let us say that I wanted to read topic number 3. Okay, topic number 3. Assume that we do not even have an idea about a topic number. I wanted to study about normalization topic, right? So now I need to search the entire book. I need to scan the entire book where the normalization content is found. If the index table, the index page is not provided to us, which will be a tedious job, it definitely takes a lot of time, right? So now we have book which is designed with index page. Now, how an index page is created with the help of topic number, topic name, and then page number, right? So this is how we define our index page. Now, when you closely relate this with our indexing one, indexing concept is being developed on top of this index page itself. Now, index number is nothing but we have taken this to be a search key, right? So topic number will be 1 and name is ER model. Now where this topic can be found, where the content of this particular topic is found, from page number 4, right? Second topic, that is conversion of ER model into table. This is found from page number 6, right? So when depending upon the topic number, we will be retrieving where the data can be, the page number, the associated page number. So directly we jump into that page number and we will access to the data, right? Which reduces lot of scan time and then search time. And we will be very comfortable in accessing to the data at an easiest manner, right? So the same kind of flexibility is also offered by the indexing technique with respect to the database management system, which improves the performance of the database. The performance of database is increased to a greater extent with the usage of this indexing concept.